record. So this is lesson 5, function notation, using function notation to describe rules, part 2. So this is part 2 from lesson 4. All right. So the only new thing in this lesson is we're going to be learning how to use technology to graph functions in function notation. Okay. We graphed them ourselves in the last lesson with that area and perimeter problem. But now we're going to use technology, aka Desmos, to do it. And it's going to make our lives a million times easier if we know how to use it on there. All right. This is continuing on from the last lesson. We're going to know different ways to find the value of a function and solve equations written in function notation. So basically solving either for the input or solving for the output in that function, which we already did in that first lesson, and know what makes a function a linear function. So thinking back to unit 2, when we spent time graphing equations that formed a line, y'all remember that? Okay, well, functions work very similarly to those equations, and that number that's paired with your variable is your slope, and the number by itself is your y-intercept, and it makes it a linear function if it forms a line like that. Okay, so you'll see the similarities in that today. All right, here we go. 5.1, make it true. It says, consider this equation here. I want you to put a box around that equation because we're going to be using it. Remember, like we talked about in unit 2, if they ever give you an equation or a function or whatever, you're more than likely going to be using it for whatever they have you doing. Okay? It says what value of Q, okay, so we're solving for Q, because that's what it wants to know, would make this equation true when P is 7. So if they tell you that P is 7, they're telling you that P equals 7. Okay, so what do we know when we have an equation and we have a variable?
Plug it in.
We plug it in. So this is part A, and I'm going to start off by writing my equation. Okay, so there's my equation. Here's my variable. What am I going to change in my original equation? The P, I'm going to change it to a 7. So I'm just going to rewrite it. I have Q equals 4 plus 0.8. But instead of the P, I'm going to change that to a 7. All right, now I just have to simplify it. When it's set up like this, it makes it really easy because they already have all the variables on one side and all the numbers on the other. So I just have to simplify this side. What do I do first, the addition or the multiplication? I do the multiplication. Someone tell me what 0.8 times 7 is. 5.6. Okay, so I'll bring down my little 4 because I'm not doing anything with it yet, and then I simplify it. All right, one last step. What's 4 plus 5.6? 9.6. Okay, so you are going to do the same thing on part B. All right, but they tell you that P equals 100. Now, before you start on that, let me go ahead and show you number 2 so you can do it as well during this time. So this time it says, what value of P? So what are we going to be solving for this time? We're going to be solving for P. Would make the equation true when Q is 12. Okay, so this time Q equals 12. All right, so once again, I have an equation. I have a variable. What do I do?
Plug it in.
Plug it in. So I'm going to rewrite my equation. Q equals 4 plus 0.8 P. But everywhere I see a Q, I'm going to change it to a 12. So I have 12 equals 4 plus 0.8 P. Now, this one is a little bit different, but we know how to do this because we did it all the way back in Unit 2. This one's a little different because I have variables and numbers on both sides. Okay? So what do I do when I'm solving for a variable that's in the middle of my equation? I start with a term that is furthest away. So how do I get rid of this positive 4? Subtract 4. And when we're talking about the term that's farthest away, it's the one that's farthest away on the same side of the equal sign. Okay, so if I subtract 4 on one side, I have to do it to the other side. What happens to my 4s? They cancel out. Let me zoom in so y'all know where we're looking. Okay, those cancel out. What's 12 minus 4? 8. So 8 equals 0.8 p. All right, how am I going to get that p by itself? Divide by 0.8. We're multiplying these right here. So I have to do the inverse, which is divide. If I do it to one side, oh, I can't see that. If I do it to one side, gotta do it to the other side. What happens to my 0.8s? They cancel out. All right, then someone tell me what a positive or a whole number 8 is divided by 0.8. 10. So p equals 10. So p equals 10 is the only thing that will make this equation true when q is 12. All right, so you're going to do that same process for b. Okay, so go ahead and do both of those on your own. I'm going to give you 3 minutes, and then we will talk about it together. Ready, go. You finished before the timer's up, raise your hand, I'll come check it. People on Zoom, please send your answers in the chat so that I can check your answers. No one can see what you say except for me. Good, Haley. Good, Jordan. Got about 45 seconds left, so try to get those done and we will talk about them. Even if you only get one done in that time, I'm fine with that. We're going to keep talking about this throughout the lesson. Okay. Good, Haley. All right, so for B, we have our equation for B on number 1. We have Q equals 4 plus 0.8 P. And this time, what does P equal? 100. Equals 100. So I'm just going to substitute that in. I have Q equals 4 plus 0.8 times 100. I do my multiplication first, so I have Q equals 4 plus 80. And then I have Q equals 84. So when P equals 100, 84 is the only thing that Q could be that would make it true. Good, Hannah. All right, B. Same thing, this time Q is 60. So I have 60 equals 4 plus 0.8 P. So if I'm solving for P, I start with my term that is furthest away. So how do I get rid of this 4? Minus 4. I do it to one side. Try to do it to the other side. Those cancel. At 56 equals 0.8 P. Now what do I have to do? Divide by 0.8. Those cancel each other out, and P equals 70. All right, now you're probably thinking, okay, this is what we did back in Unit 2. Why are we doing it again? Well, the same process of having an equation and having a variable or an input or an output and substituting it back into your equation is a skill we're going to continue with functions. Okay, so you're going to still have to know how to do this as we move forward. So it was a good little review to go over that. All righty, here we go. I'm trying to scroll. It's literally a piece of paper. Okay, here we go. 5.2. Data plans. We're used to those. We mostly all have cell phones. All right, we have a college student who is choosing between 2 data plans for her new cell phone. Okay. Both plans include an allowance of 2 gigs of data per month. Underline that. Okay, so they both have that. And then the month, so that is not an issue. They both have that. So the monthly cost of each option can be seen as a function and represented with an equation. Okay, so we have these 2 functions right here. How do we know they're different? Okay, Hayden said one of them is just a number. It's a set price, and the other one has an equation. Okay. Also notice, and I can tell the difference. They have different names. Okay, so this is option A and B. 2 different phone plans. It says in each function, the input X. Okay, so that's the number that's inside of our parentheses, represents the gigabytes of data used over the monthly allowance. Okay, so if they go over that 2 gigs, that's what this input represents. Okay, so if the input was 1, how many gigs did they use that month? 3, because it's 1 over the original 2. Okay, so that's what the input represents. Now it says the student decides to find the values of A1 and B1 and compare them. What are those values? Okay, so this isn't really how you've seen it represented before, but we're going to kind of break down what this question is asking. Okay, so when they tell us this value on the inside of the parentheses, what did they just tell us? They told us the input for both of them. So instead of just coming out and saying the input is 1, they just wrote it in function notation. right? Okay, so we know how to read that. So what they're asking is they want to know the output when the input is 1. Good, okay, so let's divide up our section. Let's do A1 first. So I'm going to start off by just writing my function for A. Okay, because that's what they told us up here. Okay, so they want to know A1. So I'm going to write that out, A1. Can I plug in that 1 anywhere in my output? Is there a next place in my rule over here? No, so if I go 1 gig over, how much am I going to pay that month? I'm going to still pay $60. Okay, so I go 1 gigabyte over, I'm still paying the same amount. Okay, now I have B1. I'm going to write down my function for B. B of x equals 10x plus 25. All right, but this time for B, what's my input? It's 1. Is there anywhere in my formula that I can replace an x value with 1? Yes, there is 1 right after the 10. So I have 10 times 1 plus 25. All right, let's simplify it. Can I do anything to this side of my function? No, it just stays B of 1. What's 10 times 1? Plus 25, 35. So if I go 1 gigabyte over my allowance, how much am I going to be paying? I'm going to be paying $35. All right, so between the two, which one sounds better so far? B sounds better, right? Okay, if I go over, I'm paying almost half of what I would in phone plan A. Okay, number 2, it says, after looking at her past phone bills, she decided to compare A of 7.5 and B of 7.5. What are those values? Okay, so now I want you to do this one on your own. I want you to tell me what the output is when the input is 7.5 for A and B. All right, I'm going to give y'all about 2 minutes to do that, and we will talk about it together. 2 minutes. Ready, go. There will be questions like this on your quiz, just knowing that when they write it in this function notation, they're telling you the input is whatever numbers in the parentheses. Yes, ma'am. All right. So for option A, if this college student goes 7.5 gigs over her monthly allowance of 2 gigs, what is she going to be paying? 60. Okay. Because according to her function, it's pretty much just a set price. It's not changing. There's no operations happening to that 60. It's just constant. All right. Now we have B. So this one's a little bit different. What do I have to do with my input for option B? I have to plug it into my other X values, my other X values. So I have B of 7.5, and everywhere I see an X, I have to substitute it. Can I simplify this side at all? No, so I have B of 7.5 equals, what's 10 times 7.5? 75. Plus 25 is what? 100. All right, so for this option B, if you go 7.5 gigs over your 2 gigs, then you're going to be spending $100 that month on your phone plan. Okay, so which phone plan's looking better now? A. Why does A seem better?
How much you go over, it's always gonna be 60.
So no matter how much you go over, he said it's always going to be $60. Okay, I know for a fact I use more than 2 gigs of data a month when I'm on my phone, right? I use like 15. So it's nicer to know I'm going to have this $60 than end up paying like over $100 randomly. Okay, so let's keep going and see what they want to know. All right, now it wants us to describe each data plan in words. Okay, so just to keep things organized, we're going to split it up. Okay, we have data plan A. I'm going to write real small. We have A of X equals 60. All right, and then we have B of X equals 10X plus 25. Okay, we've already kind of talked about these a little bit of what they kind of mean. So someone explain to me what's happening in this first option, option A. Describe to me that phone plan. Okay, so for those of y'all at home, Hayden said it seems like an unlimited plan where you can pretty much use as much data as you want and you're going to have a set price. Do y'all all agree with that?
Yeah.
Good. All right, so we'll say, I'll try to make it short so we're not writing a bunch of words. Seems like an unlimited data plan for $60 a month. Seems like an unlimited data plan for $60 a month. Give me a thumbs up if you've got that written down. All right, now B is a little trickier because we got some equation over here. So we know that X represents what? It represents our input. And back on the other page, What did they tell us our input represented? How many gigs of data they went over the 2? Okay, so what's it look like is gonna happen for every gigabyte she or he goes over?
It's gonna make the number, it's gonna like, make everything bigger, like,
What's it specifically doing? What operation is happening right here? By what?
10.
So for every 1 gig she goes over, how much money is being added to her bill? $10. Okay, now what is this 20? Okay, so we have that. This is $10 being added to her bill for every gig she goes over. But what's this 25 mean? It's just there all the time. So what do y'all think that is? What does the number all by itself mean over here?
Is that just the price? For like, if you didn't know?
Yeah, that's probably just the standard fee for that plane, right? Because they have to make some money somehow. Okay, so this is gonna be like your starting fee. Okay, so we have a starting fee of $25, and then every gig she goes over is gonna be an additional what? $10. Okay, so let's write that down. Starting, oops, starting fee of $25. With additional $10 for every gig they go over that month. Sorry, I tried to write it as short as possible. All right, so when you're ever looking at an equation and you're trying to like break it down, see what operations are happening, see what numbers are changing and which ones are not changing. Okay, so that number that's not changing is that set fee. Okay, and then the number that's being multiplied by the input is what's being added to it if something is happening. Okay, now it says graph each function on the same coordinate plane, then explain which plan you think she should choose. Okay, so if you have 2 different colors of pins, I would color coordinate them, or I would do, if you only have a black, you can do like a solid line and a dashed line to represent the 2. Hayden, would you like another color to work with? Okay, so I'm gonna use pink for my A of X. Okay, and then I'm gonna use blue for my B of X. All right. Now let's look at it. Now I want you to think back to your goal that we wrote about linear equations, because just because we're in a new unit, I don't want you to forget everything we've talked about with linear equations. Okay, I want you to just imagine for a second that this is just like a y equals 60. Okay, so we know that when the number is paired with the x, that's our slope. Is there any x values in our equation? No, so my graph's not increasing, it's not decreasing. What's it doing? It's staying the same, and it's just a straight line at what? At 60. So I'm going to go to 60, and I'm just going to form a straight line. Okay, so if we look at it and we say, okay, Miss Frisbee went over 5 gigs this month. How much is she paying? 60. Okay, Miss Frisbee went over 9 gigs this month. How much is she paying? $60. Okay, that's how you're reading it. All right, now let's do B. Again, if you do not have another color at home, make this a dotted line so you can tell the difference. Okay, mine's going to be blue. We know that when we have an equation, that the number all by itself is our what? That's the starting price, but what's that called in an equation? There's two really important pieces of information in your equation. You have the y-intercept, and that means this number over here by the x is my what? It's my slope. Okay, it's all connected. Now, where's this graph going to start on my y-axis? 25. Okay, so I'm going to go over here to the y-axis and mark that point at 25. All right, my slope is the whole number 10. So if it's a whole number, it's understood to be over what? 1. So I'm going to go, it's a positive 10, so I'm going to go up 10 over 1. Okay, so I'm going to start at 25. If I go up 10, I'm going to be where? 35, and then I'm going to go over 1. So I'm right there. All right, I'm going to do it again. I'm going to start at this point right here. I'm going to go up 10 over 1. And I'm just going to keep doing that and form my line until I run out of graph. Okay, so then you're going to find something to connect it with or just freestyle it. All right, so now when you're looking at this line, the blue one, my B of X, if I went over 6 gigs of data, how much money am I going to be spending that month? $85. Okay. So it says graph each function, then explain which plan you think she should choose. So between those two, which plan seems better? A?
It would depend, like, if you don't use a lot of that, then
Okay.
My grandma?
yeah.
So like, mhm.
Okay, so for those of y'all on Zoom that can't hear, it says explain which plan you think she should choose. Well, if she's not using a lot of data, that's a good point. If she's not using a lot of data, B seems better. But Haley made the point that she's a college student, so she's young. She's probably using her social media all the time. She's doing schoolwork, all that jazz. So A probably seems like the better choice. Okay. A of X seems like the better plan for a college student who uses more data. Give me a thumbs up when you've got that written down. Okay. It says the student only budgeted $50 a month for her cell phone. She thought, I wonder how many gigs of data I would have for $50 if I go with option B, and wrote B of X equals 50. What is the answer to her question? Explain or show how you know. Okay, now this is very different than everything we've done so far as the function notation. Okay, I want you to highlight, circle that little function notation right there. Okay, because you're going to see this. There's not any like this on the quiz because I wanted to show this to you a few more times before I quizzed you on it. But inside this function notation, do we know what our input is? No, this time they give you a variable for your input. So we don't know what our X value is. All right, but is our entire function set equal to something? So what does this 50 represent? That's the money she spent in total. That's our output or our Y value. Okay, so this time we know the output and we're trying to figure out the input. So it says, what is the answer to her question? Basically, how many gigs did she use? So if I'm looking at my graph, instead of knowing how many gigs she used, what do I know? I know how much money she spent. Okay, so I'm looking at 50 here. All right, we looked at plan B. So what line am I looking at? Pink or blue? Blue. All right, so I'm just gonna go until I run into my blue line. So I'm right here. So how many gigs of data did she use to spend $50? About 2.5. So I wonder how many gigabytes of data I would have for 50 if I go with option B. Yeah, that would make sense. She could use 4.5 gigs of data per month because she started with 2. Does everyone understand how we got that? Because you start with, yeah, this is 2.5 gigs over the original 2. Okay, so if I was writing it just for the function, I would say B of 2.5 equals 50, which means I wonder how many gigs. So she would have 4.5 gigs of data for $50. All right, so whenever you're given function notation, always break down the different parts of your function. If it doesn't give you anything inside of the parentheses, which is where our input is, and it has a number set equal in the Y value, then you just look at it backwards. You would just go to the Y value first and then go until you run into your function to find the X. All right, and I'm going to show you more how to do that on the next thing. Okay, so I'm going to pause my recording real quick. Recording again. All right, so function notation and graphing technology. All right, when we're using this graphing technology, we are going to be using Desmos. We all kind of have a love-hate relationship with Desmos, but it makes our life easier, so that's a good thing. All right, so if you're not already there, for those of y'all watching this, you do need to pull up Desmos on your computer because we will be using it. So we have function B. What's the name of my function?
B.
B. And it is defined by this equation. Okay, so every time they give me an equation, I'm going to highlight it, put a box around it, all that jazz. All right, it says use graphing technology to find the values of each expression. Okay, so if we didn't have technology for this, I would know that for this first one, my input is what? 6. So I would have an input, I would have a variable, I would have an equation. Could I solve this? Yeah, what would I have to do? I would have to plug it in and substitute it. But if we were doing that a bunch of times, that would take a long time, right? And we would have the possibility of making a mistake. Okay. So I'm going to show you how to do it on Desmos. So remember that function and go to Desmos on your computers. So first things first, you're going to type in the function in this first little blank right here. Okay. So we have capital B, parentheses, X equals 10X plus 25. And there is our function graphed. So I just wrote the exact same thing that was on my paper. Okay, so that's what this is, and there's my line. Okay, so basically the exact same thing we just graphed on our other graph in 5.2. All right, now they told us to find the value of each expression. We want b of 6. So clicking on the little next thing down here, I have a capital B, parentheses, 6, close parentheses, and look, it tells me the answer right there. Wow. So b of 6 equals what?
85.
85. So we know that this is that same function from the last one. So if this college student went 6 gigs over, how much money is she spending? $85. All right. Do the next two on your own. I'm going to give you about a minute. Okay. Ready. Go. Give me a thumbs up when you are finished. All right, let's look at it. I've gone ahead and typed in my function input on Desmos. So when my input is 2.75, what is my output? 52.5. And when my input is 1 and 482 thousandths, what is my output? Now, isn't that a lot easier than it would have been if we would have had to deal with all those decimals? Yes, that is, doesn't that make our life so much easier? Yes. Now, same thing on part 1. They gave us the what? They gave us the input and we had to solve for the output, right? What do they give us this time? We got to solve for the input, okay? They don't give us anything inside my parentheses. That means that this number that it's all set equal to is my output. All right, so I'm going to show you how to do that in Desmos. It is equally as easy as the other way. So I'm going to clear these off. I'm going to keep my equation up there. See if I can zoom in. There, that's better. All right, so instead of just doing it like they gave me, I'm going to do capital B of X equals 93. Oh no, nothing came up this time. What do? I will show you. So what this is if you think back to the last activity we did and it had A of X equals 60, what did it form? It formed a straight line. So this is going to form a straight line at what? At 93. So I'm going to have to go up to my graph, zoom out. Look, I have a straight line at 93. So all I have to do is see where it intersects at my function. Wait, that's not my function. That's my function. Okay, so what is the X value or the input when my output is 93? 6.8. So X equals 6.8. Actually, no, that's not how you write it. I'll show you how to write it. So we have b of 6.8 equals 93. This is how you have to write it. Because you have to write it back in function notation. All right, I'm going to give you a little over a minute this time because these take just a fraction of a second longer. All right, and I want you to find these other two for me. All right, minute and a half, ready, go. There will be some like number one on this page where it gives you the input and you have to solve for the output. But I didn't put any where it gives you the output because I didn't want to give you something from lesson 5 when we had the quiz the same day. But there'll be some like that on the next midpoint quiz. All right, let's look at it. So when the input or when the output is 42.1, what is the input? 1.71. So you need to have written it like this. All right. And when the output was 116.25, what is the input? 9.125. All right. I'll say it one more time. Isn't that a lot easier than having to have dealt with all of those decimals? Okay. We would, for these two problems, if we did not have Desmos to do it, we would have had to do the same process as we did on that very first activity for all of those. Okay, so that's a lot easier, right? All right, that brings us to the lesson summary, which is on page 164. All right. Knowing the rule that defines a function can be very useful. We can find the output when we know the input. We can create a table of values, which is going to be on the next page. We're going to have functions f and m in these tables. Right, turn the page. I know, mine printed off really weird. I thought it was 3 pages. All right, so we have these two functions. All right, we have function f and we have function m. We have now learned that this equation, in both of them, tells us what? What do we use this equation for? If I knew that x equaled 0 and I had this equation, what would I do with that 0? I would plug it into the input and all throughout my equation, and what would it produce? It would produce the output. Let's try it. What's 0 plus 2? 2. What's 2 times 5? 10. That's my output. Let's try it one more time. What's 1 plus 2? What's 5 times 3? 15. All right. So these equations or these rules of your function are what you plug your input into. You plug your input into to produce your output. All right. Same for this function over here. Next, knowing the rules of the function, we can graph them. Is that on the next page? Yeah, I don't know why those tables are on one page. You can graph them. The horizontal values represent the input. The ones on the horizontal axis, that's our x. And the vertical values represent the output. What we know is the y values. All right, for function f, the values of f of x are vertical values, which are often labeled y. So we can write y equals f of x because f of x is defined by the expression 5 times x plus 2. We can write the graph using what we know about linear equations. That's what I was saying earlier. If you just want to think of a function by replacing that f of x with a y like we've always done, it's kind of easier to graph it. All right, so for function m, we can just do it like that. So here's function f, here's function m. And then they went ahead and graphed those for us. F of x, m of x. Also knowing the rules of function, we can find the input when we know the output. All kinds of things we can do. And then finally, each function here, f of x and m of x, is a linear function because the value of the function changes by a constant rate and its graph is a line. All right, if it's at a constant rate, that's defining the slope. Oops. And if it forms a line, which makes it linear. All right, so that is lesson 5.